Okay, so this week I'm going to talk about updaters, adding updaters to Manim. Okay, so one of the things, if you'll remember what we have over here from this example, what we have is every single time we have this loop we have, and in each iteration of the loop we completely redraw everything, including like these texts here. And it worked out well for us. I mean, this did exactly what we wanted it to do. I mean, there was some, we had to finagle things a little bit, but it works out exactly how we want it to work out. But what I want to talk about is what happens when things are changing, but not necessarily in a loop environment. So this is not going to be the problem that we solve for this class, but imagine you have two different dots, and you want these dots to bounce around the screen. And so maybe you just you want to have these dots bounce around the screen, and you want to have a line that connects them, and you want to maybe have that line always connect them when the dots bounce around the screen. Or maybe you do something like you use one of the Manim's built-in animation functions to like slide something across the screen like that, and you want to somehow have a label under it that slides with it as well. Okay, and so for this class, we're going to learn how to learn about updater functions. Well, we're mostly going to learn about the particular always redraw function. So what an updater function is, we will see this in upcoming examples, not in this video, but in upcoming videos. What an updater function does is it basically says, okay, Manim, for every single frame, we want you to do this updater function on a particular math object, on a particular object. So that's what's going to happen. So the project, so I'm going to teach you how to do this, or I'm going to walk through how to do this. The project that I want to go over, we're going to basically graph a function, then graph a secant line on that function, and then kind of gradually make the secant line become the tangent line. So that's ultimately what our goal is going to be, and have it do things like compute the derivative, or like show what the limit of the derivative and things like that. That's what we're going to be doing in this week. And so sorry, I had to sneeze. Similar to last week, the goal isn't necessarily to do this one particular application, though I think the application is pretty cool. The goal is to learn about updaters and always redraw and that sort of thing. Okay, so if you're paying attention to the time down here, you will see that it's been quite a bit of time since I was making this video. And I don't exactly remember where I was, but let me just go over what my goal is in this video. In one sense, I want to make the graph of a function with secant lines that get closer and closer to the tangent line. That's kind of like the goal. But really what I want to do is learn how to use updaters, learn how to use the always redraw function, things like that. So that's kind of like the main goal here, and I'm going to show you that by doing this thing with the secant line. Okay, so for the rest of this video, I'm going to show you a function in the axis class called getSecant slope group, which will actually draw the secant line for us. So I'm going to make a whole new sort of Manim thing here. So if you remember, actually I'm up here. So our class is going to be our class is going to be called secant. So that's what we have here. Okay, and then we're going to have construct. Again, all of this is normal, but I'm just doing it now to reinforce it for us. And then self, of course, this is a personal preference to make the background color maroon, aka the best color in the world. And the hex code is pretty easy, just 5 followed by a bunch of zeros. Okay. Alright, so now I'm going to make an axis. So I want to work with the function x squared, so ax is going to be a new axis, or axes, I'm not sure how you want to say that. And then x range. Okay, and I have a feeling I'm going to be using like x min and x max a lot. Well, so I'm just going to make a constant here. X min is going to be equal to -1. X max is going to be equal to 1. Actually, I want to go from -2 to 2. Okay, so the x range, whoops. The x range is going to be x min to x max. And then the y range, and I'm going to have to define these y min, y max. And again, I like defining these. So it's going to be the square function. So I'm actually going to go from -2.1 to 2.1. And then the lowest is 0. So I'm going to go -0.1. And then max, I'm going to do x, so x max squared plus 0.1, just to give me some buffer. Okay, I'm doing square here because I'm using the square function. Okay, like the f of x equals x squared function. I don't want the tips, so I'm going to say false. And then because I have it up above, for the config variables, so I don't want the numbers to be there, but if you want them there, you can put them there. And I think this is probably white by default, but I don't know. But the Texas A&M marketing guidelines say it should be maroon and white, so I'm going to make sure I do it maroon and white, so I don't get on the wrong side of Marcom. Okay, so graph ax dot plot, and I'm doing x squared, so np dot square, and then I'm going to go, what are my intervals? I'm going to go from x min to x max. Oops. Okay. And now I'm not gonna do the secant line yet. I'm gonna add that yet. So I'm gonna do self dot play create axis. So it's gonna draw the axis. Then it's gonna draw the graph. And then I'm just gonna wait for 2 seconds. And I'm just doing this just to make sure that I have everything up here correct. Before I go and try to add the secant, and I have made a mistake. Of course. Include numbers. So this is the one time where you really have to be able to spell when you're doing math. Okay, all right, and it's just going to do that over and over again. That's exactly what we want. Okay, so now I can tell you about this secant thing. So slopes is going to be what the name of the secant is. So slopes is equal to ax. So this is a method in the axis class. Dot get secant slope group. Okay, and I'm just going to make kind of the most basic thing I can do here. So I'm going to say x is equal to 1. That's the point where we want to do the secant line at. So x is equal to 1. The graph is going to be equal to this graph here. So I'm going to call this GR for graph so we don't get confused here. So GR here. Okay. Okay, so graph is the variable that this is taking in, or the parameter that it's taking in. Or graph is the name of the parameter that the get secant slope group takes in, and we're passing in our GR thing here. And then dx is equal to 1.0. That's the length that we're going in the x direction. So we're going to go 1 unit in the x direction. And so what we hope to happen, so this is 1, we hope to basically get a secant line that goes from this point to that point. So I think this is 1 and this is 2. So it should be a secant line that is drawn basically from this point to that point. And we're actually going to get much more than that if I've done everything correctly. Waiting for 2 seconds. Oh, you know what? I need to, well, you know what? I didn't do the self.play create. I didn't add that. Some of you are probably like, it's not going to work. It's not going to work. It's not going to work. And then it didn't work. Okay, so we're what's happening here? Why isn't it? So I don't know. That was weird. Okay, so it's drawing that. Yeah, so that was, I'm not sure what happened. Okay, and so the other stuff that we get is this thing here and this thing here. You know, we get the X going that way and the Y going that way. Okay, so that's pretty cool, but maybe we could actually try to give those some labels, like say that's, you know, dx and this is dy, or this is delta x and that's delta y, something like that. So we're going to come up here, and if you go, actually, sorry, I usually like to show you guys this. So I'm going to Google Manim axis. So now on this page, I'm going to find the get secant. Why is it not there? Ah, it's under coordinate system. Sorry. Okay, so get secant slope group. That's what I'm doing now. Okay, so here are all the parameters it takes in. It takes in the x value. That's where we're doing the secant line at. The graph function, that is the function that we're using. And it also could even be a parametric function. So like x squared plus y squared equals 1. Dx, now we have dx line color and dy line color. Okay, so that is we can change what the colors are. So here, the dx line color is yellow and the dy line color is white. So let's just change those for now. dx, what was it? Dx line color? dx color. Okay, I'm just going to do blue. I don't know if this is going to look good. Sorry, dy. And for this one, I'm also going to do blue again. I don't know if that's going to look good, but it's just going to, you know, change it for us. Now dx label, okay, the label for the dx line. So look, defaults to math tech for string and float inputs. Okay, so I could do, hopefully what I say, what I'm about to write will work. So dx label, and it's not a parentheses here. So what am I doing, dude? Dx label equals, I'm going to write delta x, and hopefully this will work, delta y. Okay, so now I'm going to run this. We're going to see what happens. Okay. Okay, so maybe those blue colors aren't so great, but it does what we want it to, right? We have delta x here, delta y here. Now, one thing that we might look at, so forgetting about the color is kind of nauseating and hurting my eyes, but forgetting about the color for now, maybe this secant line is a little bit too long, and maybe you don't like the color either. So I can come over here, secant line color, I can change the color there, and secant line length, I can change the length. So I'm going to change the length. So secant line length. Okay, so now there's a number of ways to do this. So I basically just want it to go a little bit, I just sort of want it to go, I mean, there's a number of ways to think about this. I just want it to go from maybe, let's say, here to here. Actually, sorry, the colors from here to here. It's not so bad that it goes off the page like that. I don't know why I have a problem with it. Really, I just want to show you how we can change the secant line length. So I know the distance, you know, we're going 1 here, 1 here. So the coordinates of this point are 1, 1. The coordinates of this point are 4, 1. So delta x is 1, delta y is 3, so 9 plus 1 9 plus 1 is 10, so I'm going to say the square root of 10. That should be roughly the length, and then plus 0.1. We're going to see what this looks like. Okay, so that's not quite far enough. I'm not really sure why. There might be some sort of buffer that it does automatically, or it's possible that I messed the math up, but I don't think so. It's 1 squared. Okay, so they might be doing different scales here. So let's just do 4 plus 0.1. Okay, still not quite what we want. Let's do 6 plus 0.1. This is exhilarating to watch, I know. Okay, there we go. Now, again, it's not so bad if it goes completely off the screen. That's okay. I mean, it is a line, so the secant line does go off in both directions infinitely. Okay, so that's it for this video. In the upcoming videos, I'm going to see how we can sort of make this length go down to that and kind of some good ways to make that happen.